This video will explain how to use the chemagic modeling software online. First of all, thank you very much to the folks who made this readily available for us on the internet. It is an amazing software program that you can use to replace the modeling kit traditionally used in a chemistry class and use it as an online tool. When you open the software, you're going to have a base model here. If you wanted to start with a different model, you could load models from the Load Models section, including going to the Draw image and allowing you to draw a model and use it. If you're using this as a modeling kit, it's best probably to replace atoms on your base model in order to create the different molecules that you want. And so we've got methane here, carbon with 4 hydrogens. As you can see, it's a nice tetrahedral shape. If you'd like to see the shape from different angles, you can just click on the screen and move it around. And let's say, for example, instead of methane, we wanted to make water. How would we make that? So you're going to click up here in the Atoms and Bond Edit, and you're going to find that central atom on water, which is the oxygen, and you're going to replace your central atom with it there. The software is super cool in that it knows that oxygen can only bond to 2 hydrogens, not 4 like carbon, and so it automatically removes 2 of those hydrogens and shows you your H2O or water molecule. And it shows it in the correct geometry, the bent geometry. Similar to a modeling kit that you would use in the classroom, though, with the plastic parts, you don't have your 2 lone pairs shown there. They're just kind of assumed. And this works for all of these models here. If you wanted to, say, form a longer chain, you would need, say, carbons to form that chain. Let's make a 6-carbon chain here. You can see I'm just creating carbons where there are hydrogens. I've got 3, 4, 5. My last one, I found it actually works best to click and drag to connect them. So we connect the hydrogens. It's going to form a hydrogen there. And then I just replace that hydrogen with a carbon, and I've got my 6-carbon chain. What if I accidentally had, let's say, an extra hydrogen that I'd stuck out there, a couple of extra hydrogens, which makes it not a correct molecule? You can hit correct hydrogen and it removes any extra hydrogens. So that way all of your atoms have their octet. In addition, if let's say I've created some sort of molecule that I don't want, put a sulfur in there and a phosphorus, maybe another sulfur there. I want to get rid of a couple of those atoms, maybe not all of them. I can click here at X atom. This gets rid of one of the atoms. You can see I've got like a lone hydrogen out there now, and get rid of that with X atom. X bond, of course, removes a bond. So if you want to get rid of a specific bond, you can do that. And then X molecule gets rid of the entire molecule. So if you accidentally got these 2 molecules here, you can shrink it down. If you accidentally get rid of all your molecules, oh snap, what are you going to do? Well, you can go to Draw and then just load that model, and you can start from there. Because if you didn't want sulfur difluoride, you could put in a carbon and build whatever it is you wanted. There's, of course, different ways to look at the model. So you're right now looking at the ball model, but we could see Wire's model as well, or the space-filling model as well. That's a funny molecule to be using. Let's use something a little bit simpler. Let's go back to our methane. There we go. If you want to see, if you're learning about hybridizations, you can click on the hybridization structure, and it'll show you the hybrid molecules in there, where those orbitals would be, which is pretty cool. In addition, you can show the charge on the different molecules. Methane, being essentially nonpolar, has no charges. You can show dipoles. Again, there's not going to be any dipoles really in methane, but what if I were to stick a fluorine on there? Then we're going to see a much stronger dipole towards that electronegative fluorine. And dipole net shows us the overall direction of our dipole. And I believe that's bond energy, but I don't know. This is something that I am still learning. But the reason I made this video is so that people can use it to kind of get a start and play around with this modeling software, which is really cool. Thanks again to the folks who made it, and enjoy.